Hi all, I am Roshni Alex, Assistant Professor, Department of Electronics, MES College, Marampally.
We will discuss the I2C programming in this video. We can program the TWI in two modes, that is in the master mode and in slave mode. Again, in either mode we can read, also we'll see the programming steps. To work in master operating mode, we must be able to initialize the TWI, transmit a start condition, send or receive data, and transmit a stop condition. So in this video we are discussing only the master operating mode, that both transmission and reception we will be discussing. So first step is the initialization. In the initialization we got two steps. We set the TWI module clock frequency by setting the values of TWBR register. For that, we'll use the equation shown in the previous video, and the TWPS, that is the prescaler bits in the TW status register. And in step 2, we will enable the TWI module by setting the TWEN bit in the control register to 1. So this is the initialization. Next we go to transmission of start condition bit. For that, the first step is to set the TWEN, TWSTA, TWINT bits of TWCR to 1. So EN is the enable bit, STA is the start bit, and TWINT bit, we write a 1 to this bit to make it clear. And this enable bit, the TWEN should be set each time we send something. That is, before sending a start bit, an address, an acknowledgement, data, and a stop bit. Each time we need to turn on the device. In other cases, that is in the case of USART or SPI, we need to turn on the device only once. But in this I2C's case, we need to enable the device each time we send a bit. So to send a start condition bit, we are setting all these bits in the control register. Now we check the TWINT flag in the control register to see whether the start condition has transmitted completely. That is, this bit will become 1 after the start condition is transmitted. Then next is sending a data. For sending an address and data, we follow the same steps. That is, first we copy the data byte. If we are sending the address, then the address byte will be copied to the TWDR register, or if we are sending the data, then we copy the data to the TWDR register. First we will see how the address is sent. For that, we'll take the 7-bit address of the slave device, and it is moved to the TWDR along with the 8-bit as 0 or 1. If you are transmitting, that 7th bit will be 0. If you are transmitting, if you are reading, then reading or receiving, then that will be 1. Okay, so that data or address will be moved to TWDR register. Then we set the TWEN and TWINT bits of the control register to 1 to start the sending of the bytes. Then we poll the TWINT flag, or poll or wait for the TWINT flag to be set, because only after the transmission of complete bits this flag will be set to 1. Right after the start condition, we should transmit the slave address and write. That is what we have sent now. And after this bit is set to 1, that TWINT bit is set to 1, again we do the same for sending data. Now we have sent the address byte of the slave after receiving the acknowledgement, we send the data to the slave. For sending data, we follow the same steps, that is copying the data byte to the TWDR. Then we set the enable and INT bit to 1 of control register. Then again we wait for the TWINT flag to set. So that's all for transmission of data. Then after the transmission is complete, we send the stop condition. We come to this stop condition. To send the stop condition, we set the TWEN, TWSTO and TWINT bits of TWCR to 1. So this is how we transmit a data to the slave. And next, if we are going to read a data from the slave, we'll see what all we do. Again, we will transmit the start condition. Then we will send the address of the slave. Only difference is that the 7-bit slave address will follow the bit 1. 7th bit will be 1 for reading. Then we receive data. For receiving the data, we will send the TWEN and TWINT bits of TWCR registered to 1 to start receiving a byte. If you want to turn acknowledgement, to return the acknowledgement after receiving the data, you should also set the TWEA bit of the TWCR register to 1. Then again call the TWINT flag in the TWCR register to see whether a byte has received completely. If it is set, then copy the received byte from the TWDR to another register to save it, or give it to a port to display it. Can do anything. Then after the completion of data transmission, we will send the stop condition. So this is all about receiving a data. Hope you understood well. Moving on to a program for how a master writes a data F0 1111 to a slave with address 1010000. See, the address is only 7 bits. And this is the data to be transmitted F0. So first we initialize the stack pointer. In this main program, the above said programming steps are written as subprograms, and we just call them in the main program in the sequence we need. So this is the initialization program. This is the start. We are just calling them into this main program for sending a start bit. Then the address is sent and it is written. Then the data is sent. Again we call the write program. Then we send the stop bit. So this is the programming sequence. I'll explain the programming. Initialization. We are making R2 equal to 0. Register R2 to 0. And it is moved to TWSR. TWSR, here we are setting the prescaler bit to 0. Then we send this 47 to the bitrate register. So we calculate, set the clock frequency to 50 kilohertz for 8 megahertz clock frequency. We find this 47 from the equation given for the TWBR, and that value is moved to TWBR. Then we are enabling the, we are turning on the I2C device for transmission. It is moved to TWCR register. Then to generate the start condition, we are setting the TWINT, TWSTA and TWEN bits of control register. And then we are waiting for the TWINT flag to get set. We are writing a 1 to the TWINT bit for making it 0. Now after writing a 1 to this bit, we'll make that bit 0, and then we are waiting for that bit to get set. Then after it is set, we are returning from the program. Then moving on to the write subprogram, the data given in the data register is moved to R27. The R27 is loaded with the F0 in the main program. I'll show you here. Here first we are sending the address of the slave, and this data is moved to the R27. This is the 7-bit address and 8-bit is set as 0 for the write, and then we are calling the write program. In the write program, that data in the R27 is moved to data register, and we are enabling the INT and enabling the device, and we are waiting for the data to be transmitted. Now this is the stop bit. This is how we generate the stop bit. We will enable the set the TWINT stop bit, and we are enabling the I2C device. So coming back to the main program, we are calling the initialization of the program, initializing program. Then we send the start condition. Then we send the address of the slave, and for sending the address of the slave, we are calling the write program. Then we send the data. Again we call the write program. Then after the transmission of F0, we will call the stop bit generation program. So this is all about programming of I2C. Thank you for listening.